So this is the question related to the gravitation, and it has been asked in 2025 IITJEE Mains. So let us solve this question. Two planets A and B are orbiting a common star in circular orbits of radii Ra and Rb respectively, with Rb is equal to 2Ra. The planet B is 4 square root 2 times more massive than planet A. So the ratio Lb upon La of angular momentum B of planet 2, that of planet A, is closest to integer. So here it is basically asking the ratio of the angular momentum of the two different planets A and B. So you have to find the ratio of two angular momentum of two planets, right? So firstly हम क्या देखेंगे कि what are given. So what are given and what is being asked. So ratio of the angular momentum is being asked, and what are given is that the first thing is given is that RB, relation between the two radii is given. RB is equal to 2 RA, right? And second is given that the mass of planet B is 4 square root 2 times that of planet A. So two conditions are given, right? And with the help of this, we can find the relation between the ratio between the two angular momentum. So by definition, angular momentum is given by mv/r. So this is the general formula, okay? This is the general formula. Angular momentum L is equal to mv/r. So you have to find the angular momentum of planet A, angular momentum of planet B. So here angular momentum of planet A, that is La, is equal to mass of A into velocity of A into radii of the orbit in which the planet A is revolving. So that is the RA, right? Similarly, LB is equal to MB VB into RB. So these are the two relations for LA and LB, and where VA is the orbital velocity of the planet A and VB is the orbital velocity of planet B. So what are they? So VA is equal to square root GM, mass of the star planet, GM upon R A. VB is equal to square root GM upon RB. Now substituting these VA and VB in these equations, we get LA and LB. LA is equal to MV VA. So VA is equal to MVR. So VA is equal to square root GM upon RA into RA, right? And here, so LB is equal to M. Here the mass, here C, MA VA, so also here it is MA. So MB VB RB. So MB VB is equal to square root GM upon RB into RB. So here it is important to mention that M is the mass of the common star, mass of common star about which two planets are rotating. So now simplify this. So what M, this will be equal to M A square root G M R A, right? This is the LA portion and this is the LB portion, equal to MB square root GM RB. Now dividing the two, we get LA upon LB. LA upon LB. So LA MA square root GM RA upon LB MB square root GM RB. So what we get equals to MA upon MB into square root RA upon RB, because square root GM cancel out. So what we get, LA upon LB equals to this much. Now we will utilize the relation between MA MB and RA RB. So you can see from the question that it is given RB is equal to 2RA. So this gives RA upon RB is equal to 1 upon 2 and MA upon MB equals to MA upon MB equals to 1 upon 4 square root 2. So now substitute these values. MA upon MB is equal to 1 upon 4 square root 2 and RA upon RB is equal to square root 1 upon 2. So what we get, 1 upon 4 into 2, that means 1 upon 8. What is cost asking the question? LB upon LA, not LA upon LB. So this we find the ratio LA upon LB and question is asking the LB upon LA. So LB upon LA is equal to 8. So this is the required relation in the question. So closest integer for the ratio LB upon LA is 8. That is the answer. So उम्मीद है कि आप लोगों को ये सॉल्यूशन हेल्पफुल रहेगा.